In fact, I also had a comment on that statement that it's easier to learn imperative programming, and that some people would disagree. One thing that is known to be very difficult is logic programming, Prolog. I knew a woman who taught logic programming in Buenos Aires, and she said that they had been very successful teaching logic programming to 7-year-olds. So it seemed like the thing that was making it difficult was that if you had sort of preconceptions about how programming was supposed to be like, then Prolog is really, really difficult because it's so different. We also heard a very entertaining talk down in Freiburg at a conference where they were using Erlang to teach programming to high school girls. And one of the things that we often find difficult is recursion. They didn't find recursion difficult at all. It was perfectly logical to them. So they were doing Erlang programming, and actually, after a few lessons, we're doing a chat server. And that kind of just puts everything on its head in that what we perceive as difficult. I had difficulty learning Erlang. It took me 3 months to unlearn object orientation. Luckily, that was long ago, so I've almost forgotten it. But it took me 3 months of just careful study, trying to map all the concepts and figuring, yeah, you can do it this way too. It's different, but it kind of achieves the same thing. It took me 3 months. After that, it was okay.
Isn't the question that it must be some marketing machine behind? I mean, with C++ and Java, I mean, I remember some sessions with some computer systems. I mean, they always raise their voices saying Java, Java, Java all the time. And always trying to really sell functional programming.
I'm not sure what the question is.
I mean, we want the functional programming to take on, so to say, but I mean, mustn't there be a marketing machine behind? Doesn't help that.
So let me comment on that.
Oxford and Cambridge people. I mean.
Yeah, let me comment on that a little bit. Obviously, one of the things that we've thought about at Galwa is, does it make sense for us to try to be the Haskell company that is going out selling Haskell and so on? But actually, it's really hard to make a business out of selling a language. And so we're in a situation where there isn't a big marketing machine at all. If you ask what was Sun actually getting out of Java, what was its benefit? Well, it certainly sold some code stuff, but I think its main benefit was trying to stick it to Microsoft. I don't think they actually got financial benefit directly out of it. So it would be really hard, I think, actually to run a business whose sole purpose was selling a language. On the other hand, lots of languages have been really successful without big, heavy marketing. If you just think about how successful a language like Perl has become, there's no big marketing engine behind Perl. I think it's quite possible that functional languages may take off in that kind of way.
Marketing is not needed when you have a product or something.
Right. I guess I'm more optimistic as well. If a boat is sinking with 100 people on board and you scatter some lifebelts in the region, then they'll probably swim and cling onto them, right? Just because lifebelts float. So if functional programming is good stuff, right, and is like this granite, then we'll end up with people clinging to it. We won't have to sell it to them. What sinks?
Granite sinks.
So I shouldn't mix metaphors. So I'm optimistically hoping that the truth will out, whether or not it's marketed.
When I was a student, I had to read the boring books like Introduction to Quantum Mechanics, but then we had these Feynman lectures on physics that were very interesting. And what about books about functional programming? Will you make it to the popular culture, so to say?
I'm not writing a book about functional programming.
You've already written books about functional programming.
Oh, that's about the implementation. Well, about programming.
So I think we must mention Joe Armstrong's new book on Erlang, which certainly one book that I looked was well up in the top 100 computing science books on Amazon.
It's number one in parallel programming on Amazon. It's more popular than C books on C++.
so
selling very well. Yeah.
if you care about
Well,
parallelism,
it's a different style. I mean, I didn't use the word recursion until that phase 20 years. I just wrote things like variables that don't vary.
I think it wasn't that many years ago. There was a book about, I don't remember if it was Scheme or Commonlist, was the most sold book on Amazon in computing.
Was that Abelson and Sussman, perhaps?
I think so.
Structure and interpretation of computer programs?
Something like
Yeah.
that. I don't exactly remember which book it was.
But actually, the people who should write books are kind of you guys, really. Once you've, because it's
But I think it's
less convincing coming from the comments.
what John said. One of the Johns.
You have a question with you?
Almost you almost answered my question, but well, functional programming was around for so many years. What has changed? What would be the top 3 things you think has changed recently that suddenly makes it sexy? You mentioned multi for modeling, and well, for modeling I have a counter argument why it's not necessarily a function language is the best tool, but what would be, in your opinion, the top 3 things that have changed recently that makes it really suddenly so hot and interesting, and why it should be used more by usual programmers developing usual systems?
Scale. Aside from parallelism, that I think that as people write larger software systems, it becomes harder to get them right, and the costs of getting them wrong increase. And so, in the early days, people could produce software systems, and they could have the odd bug, and nobody really cared very much. But now we seem to care a lot more about software errors, and invest a great deal in static analysis tools for imperative languages. And then when we start to invest in static analysis tools for imperative languages, we find out just how difficult it is. So I think, in effect, the costs of bugs have been rising. So people are looking around for alternatives. I would say that's one other reason that people have become more interested of late.
So I think another reason is that Erlang in particular has perhaps unconsciously been very well marketed. And the trouble with a language like Haskell is that you can use it for anything. And just as John said, if you can use something for anything, then why should you use it for anything at all? But Erlang has always had a very strong focus on a particular application domain, namely telecoms. And then it turned out to be very fortunate that also suited the internet domain. And the story of Bluetail, which I don't know, I'm assuming everybody knows it. I'm sure Joe could tell it much better than I can. But the startup that Joe was involved in that was sold for $140 million, was it? 54. $154 million after less than 18 months. It's the only Swedish technology startup that has been sold before having time to file its first accounts. That story is something which spreads. And I think through having a clear focus on a particular application domain, now lots of people who will be thinking about building an internet system that needs very high availability, a lot of robustness, great scalability, they're going to consider Erlang as a possible choice. And that, I think, is an effect that is just growing and growing.
Yes,
Joe.
just going to say, I meet a lot of people, they ask the same question. The other thing that seems to be happening in Java, C++, Ruby is disillusionment. You know, that they thought that these new languages were going to solve a lot of problems, and they become disillusioned with it. They realise that they have problems. So, you know, there's a lot of people switching from Ruby to Erlang for that reason. And that would probably happen with Haskell. You know, people who switch to Haskell with great expectations, then they'll become disillusioned. Yeah, and same with that. It's part of the life cycle of languages.
But I think it's also important not to expect any new idea to take over the world in 12 months. And that's not how new technologies are introduced. You start off small and grow, and as long as you're growing fast, then it doesn't really matter how small you start.
The other reason I think is that if you look at languages, it seems to me that they come in threes. Because, I mean, you've got Java, C++, C#, you've got Perl, Ruby, Python, and you've got Erlang, Haskell, Camel. And you sort of amortize the cost of learning those over the three languages. If you learn one of them, the act of learning the other two becomes a lot easier. So once you don't really know what an object-oriented language is, but once you've learned one of them, you sort of recognize the same stuff. You've learned to do object-oriented programming when you did the first one, and then if Java wasn't for you, you could convert to the next one rather easily. I think that's the same function. Like once you've got this idea that this shouldn't have mutable state, that's a key idea. And once you've learned that, it maps onto the other languages. So this gives people choice, because I wouldn't say Erlang, Haskell, and Camel are suitable in the same problem domains. And from 5 years ago, when we were saying we can solve all problems and we're ever so good at everything, we were saying, no, well, maybe if you want to do, image processing or something like that, use Camel. If you want to do communications, use Erlang. If you want to write domain-specific languages, use Haskell. And it's a kind of that's what you would see in the object-oriented language. If you want to do that, use C++. It's that kind of level of maturity which you see.
I have another theory, and that's one thing that has changed in the past years is, and this is very obvious in the media world, is that the cost of distribution has gone down tremendously. Paul Graham, for example, if you haven't read his essays, you might want to do that at paulgraham.com. They're very amusing. He would talk about how, for example, bloggers are starting to compete with traditional newspapers. And in the past, if you ran a newspaper, what the real benefit or the thing that you needed to own was the distribution channel. And it was really expensive before the web. It was really expensive to distribute news, no matter how you did it. If you would print leaflets or print newspapers or broadcast television, it was extremely expensive. It required infrastructure. Now we have sort of this universal infrastructure that allows a small group of geeks to form a small company. They can reach customers all over the world. And as we know, the production cost of software is very low. And distribution nowadays is fairly low. And so suddenly you can be very successful with small teams. So then it becomes very interesting to have tools that are extremely productive for small teams. But in the past, where you had the winners were really companies with 100,000 employees. I can't think of any companies that big, but you would own the infrastructure, and that's how you beat your competitors. And then cost of developing software, who cares if it's 10 times higher than your competitors? It's the distribution that decides whether you win or not. And that's changing, I think, in a lot of domains.
Yeah, if you look out the window down there, you'll see a little white tower standing up. It's got a little column at the bottom, and in there you've actually got a base station. You spat that way, you needn't look now, but later. You've all seen it. In that base station, there are 6.5 million lines of C++ code. There are also a few hundred thousands of lines of Java code. Now, realistically, we're not going to rewrite that in Haskell or Erlang or anything. We're making money by selling them now. So my point is that if you have that sort of thing, that you're going to use the technology you have. If you're going to come along with Haskell or Erlang or anything else, or Camel or make new systems, it's going to be in a new niche, a new domain. And my question to you is, what new niches and what new domains do you see that sort of coming in and using for functional languages?
Finance. Actually, last CUFP, there were lots of talks from big banks. Essentially, every big bank seems to be Barclays and Arnambo and SocGen and Credit Suisse. They're all doing functional programming stuff. So that's one.
So at the Johnson Functional Programming event that I organised a few months ago, half of the companies who took part were in finance. And indeed, the work that Simon's done on financial combinators is part of the reason for that.
So that's made you rich.
I wish.
But actually, that's a fair question, because most of the financial work, I guess, is also not real time in that sense. And whereas the base station, that's a real time thing. Maybe some of the software you have even for the crypto, with the exception of this file server here, are not real time. They are things that can take time to compute. So
even the file server is not hard real time. I mean, you want it to be responsive, but you actually have flexibility. Yeah, and so I would say at the moment, a language like Haskell is not appropriate if you're wanting real time responses.
Please stop the car now.
Yeah, so I wouldn't write control in an aeroplane, for example, in Haskell, but I wouldn't write it in Java either.
But you might write it in an embedded language written in Haskell that generates something, right?
Absolutely, yeah.
So I think it's not true to say that financial software is not real time. If I look at Jane Street, who are one of the companies that was at the Jobson FP event, they use OCaml to write program trading code. And one of the reasons that they like OCaml is that it runs considerably faster than their old code, which is, I think, in C++. And if they can trade a few milliseconds earlier, then in their market, that means they make more money. That's very real time.
A good trader needs a special button even for the right fields.
fair enough, but I was talking mostly about the financial algorithms that would be.
Yeah, so I think the applications for which you need the kind of absolute guarantee that you'll respond within exactly so many microseconds, practically in assembly language, and for everything else, and even responding in a few milliseconds. So usually writing in a function language is going to be just fine. Very, very rare, I think, for your deadline to be so firm that you want to pay the cost of writing in machine code.
And indeed, for Jane Street, one of the reasons for using OCaml is just performance.
Right. But they probably don't have as much predictability. If it had to be, with absolute guarantee, or 100 people die, then you probably think again. And be less ambitious, much less ambitious, much more expensive, and writing in some lower level.
Well, asynchronous.
Yeah.
Do you feel that it's an impossible property of a functional language to have that kind of responsiveness?
It's difficult because the level of abstraction is pretty high. So I think if you want this kind of predictability stuff, you're going to have to make some linguistic compromises and design a language for that purpose.
And indeed, if you look at a language like Lustra, which actually is a functional language, but it's designed for this kind of system, there are certain capabilities that Haskell has that are in Lustra, and there are certain capabilities that Haskell has that are not in Lustra. So you actually have to be very restrictive on what language capabilities. So can you have functional languages in that space? Absolutely, but they have to be custom designed for that space.
And you give up quite a lot else. Yeah.
Actually, I think at least as big a problem in that domain is the architecture of modern processors. It's a much bigger deal if you miss in the second level cache than if you're running a Haskell program.
So I have a related question. You said earlier that you couldn't write the security part of the file system in Haskell. So you need to translate that to C. And the reason you did that was to get some additional properties that weren't in the original design. But since you're previously at least, your company worked with translation, did you ever consider machine translation from your Haskell model into C with those extra properties?
We did, and what we actually ended up doing was writing the Haskell in a style that was able to be directly translated into C. So it's actually easier to convince somebody of its correctness by just putting the Haskell down there and then the C code beside it and saying, look at the line-by-line correspondence between them, than it is to say, let me convince you of the correctness of this translator, which takes this code and produces that code. So again, thinking of our customers and what will it take to convince them to put their stamp of approval on it, doing a hand translation was the right thing to do.
Okay, thank
question that we touched upon with Simon over lunch is that, yeah, functional languages are implicitly parallel. They have a parallelism implicitly in them. However, both Haskell and Erlang still rely on explicit threading. What do you see happening there in the future? Will we get there where it would become fully implicit, or we will never need that, or it will never happen for this or that reason? What's your view on that?
So,
and I'm basically shooting at the multi-core distribution in a multi-core environment, automatic distribution.
I think as a part of the way we've got implicit parallelism, and we've got a project in that area that's got some good initial results where we take a Haskell program, we run it to representative data, and recompile it in order to exploit some of the potential implicit parallelism programs. But that's only going to solve part of the problem. I think the most promising approaches are the kind of things which actually Simon and Co are investigating to do, things like nested data parallelism, where you still have you don't explicitly create threads and do synchronization and use things like monitors. You say something about the parallel structure of your program for use of parallel maps and so on. Then the system can then automatically create and balance work across multiple processes. And I think being in a functional language is very important for that, because the compiler needs to do very aggressive transformations and optimizations, which are much easier to do in a functional context where you can understand where these nasty effects are. And I imagine that these things are near impossible to do in standard languages. So I think that's one of the ways in which functional languages are going to separate themselves from other languages in the future, because of their nature, they're going to be much easier to parallelize. But we're really kind of at the beginning of this process.
Let me just add a little bit, and we've got some of the stuff that we're doing where we naturally have written some of the code using forks and things like that, just because it actually makes the code cleaner. And things like forks are actually relatively cheap in Haskell. And there are other places where we just put in parallel combinators and say, do this stuff in parallel. So we've reached nothing like the sophistication that Satnam has of actually trying to derive this automatically. But we found often it's the case that a cleanly written Haskell program has lots of opportunities that by adding the notion of just saying, do this in parallel, you don't actually need to rewrite the code. And if you are thoughtful about that, we've found that we've been able to take things that were written originally for single processors and just have them with very modest changes run very well on multiple systems.
That's it. I don't believe in parallelism without tiers. You know, take your random program, shut your eyes, throw it into some mysterious and wonderful compiler, and lo and behold, it runs on 100 processors. It just isn't going to happen. To get a program to occupy 100 processors, you have to think about it. You, the programmer, have to think about it. So the issue becomes not automatic parallelization. It becomes, how can you allow the programmer to express their sophisticated thoughts about how to do this algorithm in parallel in a way that's clear and perspicuous, that lets them and the computer understand how to do it. And I think we've got the best chance of doing that in a functional setting. But I really don't buy complete auto-parallelization at all. Yes, there's a way. You've got an 8-processor machine on your desk. You might as well have a go. And if it uses 2, then that's better than not using them, because after all, they're there. But
so can I just comment on that? Because as far as I'm concerned, there's sort of real parallelism. So there are 5 people here. That's real parallelism. And if you've got a quad-core computer, you've got 4 cores on it. That's real parallelism. And then you've got pseudo-parallelism in your programs, where you say par begin or par end, or do this p-map, map this in parallel. And that has to be mapped onto the real parallelism in the processor, because in the processor you've got, unless you build your own custom FPGA, so it's completely different. There it might be that Haskell is something like that is the only way to program these things, because the alternatives are so complicated you can't do it. But if you've got a language like Haskell or Erlang or Camel, it has to map onto the real parallelism in the hardware, because everything else is an illusion. So you've got multi-cores, which you can map onto because it's rather easy, but the cost of spawning a computation on a remote processor and collating it and getting the answer back might be more than the effort of doing so. I think the programmer has to annotate the program and tell it which it is. Then you've got instruction level parallelism and deep pipelines, and you've got memory parallelism. But those are very, very difficult to exploit. I mean, you're not going to change the pipelines in the processor. So basically, you've only got the multi-core type of parallelism, and I don't see you have to understand that. You have to understand the mappings between that to get real performance out of it. You can get some gains, as John said, by just parallelizing something and hoping that it will go fast. I don't think you can have real gains until you do an explicit mapping.
Right. Well, I think I disagree with you a little. It seems to me that the ideal situation is that for a modest amount of care and thought by the programmer, that they ought to be able to write a program which is flexible on the number of cores, say from 1 up to a certain number of cores, and that you may then just simply use a compiler option to be able to select it.
But you're going to have the problem. So I want to do these 20 things in parallel, but I've got 4 CPUs. So 4 of them are really done in parallel, the rest is an illusion.
Absolutely,
So
but
you
that's
have to
fine.
understand that. Although it might change radically if we get sort of 1 million CPUs, which we should get by 2029, whenever it was.
Well, in telecom systems we have thousands of explicit parallel processes, at least in the Erlang-based systems, and we had it already with a single core processor. So that's the problem. Is models like that we have process per call or half call or things like that, and so having automatic parallelization, P-map, for example, for each of these thousands of processes, it might be counterproductive. So I don't think it's a good idea in these systems to have.
I think you're right. In your application area, you have the joy of a sort of inherently parallel application.
Real world is parallel.
And that's right. So, and that's really good. But not every application is like that.
But our applications, not like
yeah.
I'm curious, you said that your developers, John, that the developers got really productive when you started using the functional programming. Was that developers schooled in functional programming, or just your ordinary C hackers exploring functional programming and suddenly getting very productive?
So one of our not-so-secret secrets about Galwa is that when we hire people, with very rare exceptions, we hire people who are already skilled in one or other functional language. And we do it not because it's going to be easy, therefore, to teach them functional languages. But what we've found up to this point is that people who've gone out of their way to learn functional languages are among the top few percent of programmers. And that also is a tremendous benefit for us, that we then get really good programmers who are able to cope with the abstractions very nicely, very well. It'd be interesting to see, in 10 years' time, if and when our predictions have come to pass that functional languages are mainstream, whether that's still the case or not. I mean, nowadays, if somebody says, I'm a Java programmer, that's not sufficient for you to be able to figure out whether they're a good programmer or not. But it is still the case that if somebody is a good Haskell programmer, that there are very good chances that they're a great programmer.
Haskell's informal motto is avoid success at all costs. So with any luck, it'll still be true in 10 years' time.
I think it's time to have a little prize ceremony. And you all win first prize. I hope that there are enough prizes in here. They're different colors. Are they?
It's a base station.
Ericsson's new
mini base station. Mini here is 100,000 lines of C++ code.
Watch out for coming. I don't know about you, but I've had a great time. I am very satisfied, and I'm very satisfied that so many people came. I'm also a bit satisfied that not everyone who signed up came, because we would have had a big problem. I did check. We could not seat more than 200 people in this room, and there were almost 300 people signed up. So we had good turnout, and so I want to thank you all for coming, and I want to thank the speakers for an excellent and very interesting day. And many of you certainly have signed up for the Haskell tutorial tomorrow, I'm sure. That will be in Edinburgh, in Rudahuset, in the big conference room there. And there will also be a hardware workshop in the conference center. Now,